Okay, I'm going to do some review for your test, and I'm going to take some of the problems from the quizzes that people had the most trouble with and just go through them and work them. So if you get out your quiz and you can kind of follow along, especially if you had trouble with them, and hopefully this will clear up some of your confusion. The first one we're going to do is number 2 from week 16, homework quiz 12, chapter 8. And it says, write a balanced molecular equation for the reaction of barium chloride and sodium sulfate. Indicate which product precipitates. So you have barium chloride and sodium sulfate. They're both aqueous, which means they're both dissolved in water, and they're ionized. So remember when we learned about ionic compounds, when you dissolve them in water, they no longer exist as the compound, but they exist as the individual ions. So, for instance, we have barium ions, which are +2, chlorine ions, which are -1, barium being from group 2, so it's always +2, chlorine being from group 7, which is always a -1 ion. We have 2 chlorines attached to the barium, which means when they become ions, they exist as individual ions, so now we have 2 of them floating around individually. Then we have sodium sulfate. So the sodium is from group 1. It has a +1 charge. There are 2 of them in this molecule, so when it ionizes, there are 2 individual sodium ions moving around. And then we have the sulfate ion, which is SO4. The polyatomic ion has a -2 charge. And remember that the polyatomics are always treated as a unit for this kind of a problem. So we'll treat that as one thing, just like the sodium's one thing, the chlorine's one thing, and the barium's one thing. So those are the charges that we're working with. Now we look at this and we're trying to decide what are the possible products from this reaction. And this is known as a double displacement, which means that the cations and the anions can swap and form 2 new possible products. So the barium, which is +2, can possibly join up with the sulfate to give us barium sulfate. Right? Barium's a +2, sulfate is a -2, so 1 barium and 1 sulfate would give us a total charge of 0, because +2 and a -2 makes 0. So that's that one. And then the sodium can combine with the chlorine. So the sodium's the chlorine. The sodium has a +1 charge. The chlorine has a -1 charge. So +1 and -1 gives you 0. So that's also a 1-to-1 ratio of sodium to chlorine. But we have 2 of them. Each of them we have 2 of. So put a 2 in front of that to show that 2 of these and 2 of these makes 2 molecules of sodium chloride. So these are our possible products. Now the second part of that question is indicate which product precipitates. So we go to our solubility rules. We know from our solubility rules that sodium, being in group 1, is going to be soluble, because anything in group 1 is always soluble. And generally salts of chlorine are soluble too. But rule 1, which is the group 1 rule, trumps everything. So this one is soluble, so we're going to put a little AQ there to indicate that that one's soluble. So barium, if we look at that, we have a rule for sulfates. That is rule number 4, which says that most sulfate salts are soluble, but there are some exceptions, and one of the exceptions is barium sulfate. So that one's going to precipitate, and we're going to put the little S in parentheses there to indicate that that is the product that precipitates. So that's the answer to the to question number 2. And now we'll move on to question number 3. Okay, question number 3 says write the complete ionic equation for the above reaction. So, in order to do that, we go back to the ions that we had earlier, and we write them as individual ions with their charges. So we have barium, which we've already established is a +2 because it's in group 2, plus 2 chlorines with a -1 charge because chlorine is a group 7 element, plus 2 sodiums. Each has a +1 charge, plus the SO4 ion, which has a -2 charge. Okay, and all of these are dissolved in solution at this point, so they're aqueous. Now, on the product side, we have barium sulfate, which is a precipitate, a solid, and we have sodium chloride, which is aqueous. The solid precipitate is not in ionic form. Once it falls out of solution and you get the sediment at the bottom of the beaker, you've got a solid down there. They are not in ionic form. They are in their molecular form, for lack of a better word. So that is going to be written as the compound because it's no longer dissolved in the solution, so it does not exist as ions in the solution. So it's written as the entire formula, molecular formula. And then you have the sodium, the 2 sodium ions, because this is dissolved, which means the ions are freely moving around, and 2 chlorines. The negative charge, and the sodium should have the positive charge. Okay, so you should have a +2 on barium, -1 on 2 chlorines, a +1 on 2 sodiums, a -2 on the sulfate ion, the barium sulfate ionic compound, and then the sodium ions, 2 of those, and 2 chlorine ions. And of course these are also aqueous because they're just floating around in solution, dissolved in solution. So that is the answer to number 3. Number 4 says write the net ionic equation for the above reaction. So for the net ionic equation, the only thing we're interested in are the ions that react and formed a precipitate. So that would be barium, let me get my pen, barium and sulfate form the barium sulfate. Everything else is called spectator ions, and you have one on this side, and you have one on this side, so they cancel each other out. Because they haven't changed from the reactant side to the product side. Nothing actually became different for them. So the net ionic equation then becomes barium 2+, which is aqueous on the reactant side, plus the sulfate ion, which is 2-, that's aqueous, and it forms the precipitate, which is called barium sulfate, and that's solid. Okay, so this is the answer to number 4, and that's how you go from the molecular equation to the complete ionic equation to the net ionic equation. Okay, number 5 says write the products that occur for the following acid-base reaction. In an acid-base reaction, the driving force for that is the formation of water. So if we look at this, we have hydrogen and this side, we have aluminum hydroxide on this side. Basically, this is like a double displacement reaction. The hydrogen is going to swap places with the aluminum. And then the aluminum and the chlorine will combine. So what you end up with is a compound formed from aluminum and chlorine, and compound formed from hydrogen and hydroxide. Okay. Now, first of all, let's look at the aluminum and the chlorine. Aluminum is a group 3 element, which means it's going to have a +3 charge. Chlorine is a group 7 element, which means it's going to have a -1. That means that we're going to have to change the ratio here. It's not a 1-to-1 ratio, and the easiest way to do that is to crisscross the charges and put them as subscripts. And you get aluminum chloride. Aluminum there's 1 aluminum, so you don't write the subscript for 1, of course. And there's 3 chlorine, so you'd write a subscript of 3. So this is the compound we're going to have for that. All right, and then we have H and OH. And the more common way to write that is H2O. But look at what we have here. We have 3 OHs here, and we have 3 chlorines here, which means that if we have 3 OHs here, we've got to have 3 H's to go with it over here. So we're going to need to put a 3 there, which means we're going to need a 3 here. We've also got the 3 chlorines that we're going to need the 3 there for. So now let's go through, and we have 3 hydrogens, and here we have 3 hydrogens, which gives us a total of 6 hydrogens. 3 times 2 is 6, so we have 6 hydrogens here. Then we have 3 chlorines, 1 aluminum, and the 3 OHs. So everything balances now. So that is our reaction. Let me just rewrite it without all the mess around it. And that is your final answer for number 5. And the final question I'm going to look at on quiz 12 is number 8. Is the following reaction a synthesis or decomposition? Remember that the word synthesis means to make something. If you synthesize something, you're making something. So, sorry, I'm getting my pen to work right here. So for synthesis then, you're taking something that's smaller and making something bigger from it. Taking small things, making big things. And specifically in a chemical synthesis, you're usually talking about taking elements and synthesizing something larger from them. So this is a synthesis reaction. The reverse of this reaction, P2S3, would be a decomposition. Because when something decomposes, it breaks down. So you're taking something larger and breaking it apart. So those 2 words, if you understand the meaning of those 2 words, you should be able to look at these and determine fairly easily which one would be a synthesis and which one would be a decomposition. And that's the end of the review questions that I'm going to do for chapter 12, or for quiz 12, I'm sorry.